Welcome to this video, explaining how to calculate the equilibrium cant for a curve. In this video, we will look at the information we need to be able to calculate the equilibrium cant. Then we will look at the equation we use. Lastly, we will look at some key things to remember when calculating equilibrium cant. So, what do we need to know? We need to know some key information about the curve we are calculating the equilibrium cant for. We need the radius of the curve, in meters. This is known as r. We also need to know the speed, most often the maximum speed permitted for the curve, in kilometers per hour. This will be known as VE. In the UK, the speed will often be stated in miles per hour as standard. We need to convert this to kilometers per hour for this calculation. To do this, we multiply our mile per hour value by 1.603. So this brings us onto the equation itself. Equilibrium cant, EQ, equals 11.82 multiplied by the speed squared and divided by the radius. The 11.82 is a constant calculated based on 1,432 mm track gauge, the standard in the UK. By putting the speed and radius values into this equation, we will get an equilibrium cant value in millimeters. There are some key things to remember when working on this calculation. Before we look at this, can I please ask a favor? If you are finding this video useful, please give it a like and subscribe to the channel. This helps me grow the channel and keep producing videos. Thank you. Back to it. When working with equilibrium cant, remember to convert the speed into kilometers per hour. This is a common mistake. The equilibrium cant for a curve is only valid for a single speed, the one used in the calculation. As you can see, one of the key components of this formula is the speed of the train. This is because the speed at which the train is traveling around the curve is related to the amount of centrifugal force the train experiences. It is very normal on UK railways to have different allowable speeds for freight and passenger trains. So the same curve could have different equilibrium cant values. But we can only apply one to the track. It is standard practice to calculate the equilibrium cant for a curve, using the maximum speed allowable, as this is the top speed a train could traverse the curve. 11.82 is a constant, calculated based on 1,432 mm track gauge, the standard in the UK for inclined track. If we were on vertical track, with a gauge of 1,435 mm, the constant would be 11.34. For other gauges, the constant will be different and may need calculating from first principles. In the description I have included a link to a detailed explanation of how this constant is derived. So remember to check the track gauge with which you are working. And there we have it. Now you know what equilibrium cant is, how to calculate it, and some key things to remember. For more on track engineering, check out my channel.